Hello. In lesson 2, we're going to be using slope-intercept form quite a bit. We're going to start out with graphing equations of lines using slope-intercept form. First thing, let me do a quick refresher of what slope-intercept form is again. For y equals mx plus b, which is something you're going to get very used to, slope is your m. That's going to be your change in y over change in x. In other words, the steepness of the line. It's how far up versus how far over do you have to go to get to the next point. For the intercept portion, that's b, and that is your y-axis intercept. In other words, when that line is drawn, where is it going to cross the y-axis? X and y, this is your ordered pair. So let me put, oh, that didn't come out right. Let me erase that part. That's going to be your xy right there. And of course, it's backwards from how you see it. The x would go over here and multiply times the slope. So when you're working with that, let me just put in a sample equation in. Normally what you're going to see, this is one similar to what we dealt with in lesson 1. What you're going to see here is a slope would be -2. Now as a fraction, that would be -2 over 1. And what you'll see me do in the next few examples is when I'm working with slope, I'll draw this out as a fraction even if it's a whole number. And to change in y, that means you're going to go up or down. A negative number will mean down 2, and the bottom you always go to the right. This negative only affects the numerator, and you'll go right 1 from point to point. Now your intercept is -2. That means your line is going to cross the y-axis. Remember, this vertical line is your y-axis. It's going to cross it at -2. If you have a slope of -2 also, then that means, as we showed right here, that you'll go down 2 and right 1 and draw another dot, and down 2, right 1, draw another dot. A 3-dot minimum is a pretty safe minimum expectation for dots. Your teachers will vary as you go into different classrooms at the high school. All right, and here is what the line would look like of y equals -2x minus 2. So that's the process that we're going to repeat in the next couple of examples. Let's look at the next one. Now I did -2x minus 2, and notice that, let me go back to that. Notice a negative slope will drop down left to right. Now what we're going to work with is a +2 slope. So on your slope here, let me put y equals mx plus b back up here. A positive slope is going to be 2 over 1. Since that's a +2, it's going to be up 2. Remember, slope is y over x. Now change of y over x. And right 1. This -2, that's your y-intercept. So here to here. So -2 again. Now with a positive slope, instead of going down 2 as in the previous one, I'm going to go up 2 and right 1. So I'll have a point here. Up 2 more and right another one. And I'm going to go ahead and draw that line in. Now when you draw these out, you want to make sure that you're crossing all the quadrants. Now on here, I'm not good at hitting a straight line, so I use my shape tool. There's a little arrow at both ends because this line goes infinitely upper right and lower left. You notice again the positive slope goes up as you go left to right. So this is the format you're looking for. Don't draw your line too short. You want it to cut across all the quadrants all the way to the edge of your graph. All right, let's clear that off. Now let's look at example number 2. Get this line out of there. All right, for example 2, you've got a slope that says -x. Now you know that that means -1x. You just don't see a 1 there. So your slope in example 2, in the equation 2, is -1 over 1. And your y-intercept is a +3. So you start out with your y-intercept. Plot any y-intercept you're ever given first. Alright, so this is the first thing you do, is plot the y-intercept. The second thing you're going to do is make 2 more points based on your map of the slope. Again, slope is y over x, change of y over change of x. That means you're going to go down 1, that's what negative 1 means, right 1. So from the y-intercept that you did first, you're going to go down 1, right 1, make another point, down 1, right 1, make another point. At that point, as soon as you hit that 3 dot minimum, you are ready to connect your lines. So, see if I can hit this. It's going to go just like this. Whoa. It should go just like that. Get rid of the ugliness and try that again. There we go. And then don't forget your arrows on the ends. I know that seems picky, but that's something that when you take your placement test, it's going to be expected that you know those should be there. So that's something I'll be looking for, alright? So there's a couple of examples of how to graph using slope-intercept form again. Now keep in mind too, if you catch this, you have a negative slope, so you know your line should be going down from left to right. Yes, this one does. Alright, next, let's look at non-slope-intercept form equations. So these equations are not in slope-intercept form. Again, slope-intercept form is y equals mx plus b. Now m, the number in front of x, is only your slope if it's in this format. If it's in another format, like over here you have a 3 in front of x, 3 is not your slope. It's not your slope until it's in this form. So what you're doing is transforming your equation from whatever format it's in into solving for y. Alright, so let's look at example 1, equation 1. I'm going to leave negative 2y on the left, but I need to get this x over to the right hand side. The way we do that is take x away from both sides. So my next step is going to be negative 2y equals negative x plus 8. And I'm going to assume that you've had enough algebra experience at this point that you can do this transformation of the equation. Alright, I'm going to solve for y by dividing both sides by the coefficient of y, which is negative 2 in this case. Now negative 2 divided by negative 2 gives you 1. So I have y equals. It's important to note that negative 2 affects the negative x and it affects positive 8. So make the mistake of only applying that negative 2 to one of these terms over here. You have 2 terms, term 1 and term 2 on the right side right now. A negative divided by a negative gives you a positive. Remember, there's a 1 in front of that x. So your slope, I would write that as a fraction, 1/2, and put the x just like this, will be 1 over 2x. Now your y-intercept is 8, which is positive, divided by negative 2, so that's negative 4. So in example 1 here, equation 1, the first thing you're going to do is you're going to plot negative 4. 1, 2, 3, 4 on the y-axis. Right, so that's where you get that point, is the negative 4. Your slope means you're going to go up 1, and you're going to go right 2 from that point to get your next point. So up 1, right 2, it's going to be right here, and a 3 dot minimum, up 1, right 2. So when you draw this in, here's what your slope's going to look like. And I have missed again. Alright, there we go. And then put your arrows at the end for a proper line. Now let's look at equation 2. Let me clear this page. Oh, that didn't work. There we go. Let me just use my eraser to get rid of that. Alright, thought I had that a lot easier to do, so bear with me a second. Okay, equation 2. On here, you've got negative y. I'm going to leave that on the left-hand side. So I'm going to get the 3x out of there by subtracting 3x from both sides. What that's going to leave me, my next step, is going to be negative y equals negative 3x plus 4. Now remember, my goal is to get it in this format, y equals mx plus b. So I want that x first. That's important. Now if I divide both sides by a negative, say divide by negative 1, you could actually say multiply by negative 1. What that does is make y positive. Now negative 3 divided by negative 1 is a positive 3. Put your x in. 4 divided by negative 1 gives you a negative 4. So first thing you do, plot the negative 4. And in this case, what's the slope? You've got a 3 for your slope. So that's 3 over 1. When you write it as a fraction, that means up 3 and right 1. So 1, 2, 3, 1. 1, 2, 3, 1. And then you're ready to go ahead and fill that line in. Just like that. And put your ends on it. And there's your equation 2 graph of that line. Alright, let's move on and look at the equation 3 example here. Nope, did it again. Get rid of all of this, and let's clear that line off there too while we're at it. Alright, equation 3. I've got 2y. Again, I'm going to get that 3x out of the left side, move it to the right. So I'm left with 2y equals negative 3x plus 8. Now divide by 2. And what I'm going to end up with is y equals negative 3 over 2 x plus 4. So again, first thing I want to do is plot a positive 4 on my y-axis. And I made that 1 too high there. Let me erase this one. Next, I want to decipher this slope of negative 3 over 2. So a negative 3 is a change of y, means down 3. And I always move to the right, so right 2. So I go down 1, 2, 3, move right 2. There's my dot. 1, 2, 3, right 2. There's my dot. And then it's just a matter of connect the dots. And put the ends on. So now you have a negative slope because I moved that minus 3 over. There it is. So it should go down from left to right, which it does. So that's a few examples of how to convert that equation and go ahead and graph those. Alright, next, sometimes you're not going to have both x and y in an equation. I want to show you how that works. Now, if you were doing a table of values like you saw in lesson 1 for these two equations, let me show you how this would work out. If you have a y of negative 2, that means no matter what your x is, y is going to be negative 2. So you can just put the random things in for x that are easily graphable to figure out whether this line is horizontal or vertical, which we'll find out which is which here in just a second. So let's graph these. 0, negative 2 for equation 1. This is where we're at now. So 0, negative 2, 2, negative 2, and then the last one is negative 2, negative 2. When you connect these, I think it's pretty obvious already that we're going to be working with a horizontal line. Now let me continue that for just a little bit. So what you need to know, besides the fact that this is a horizontal line, is how to define the slope of this line. You notice this is y equals, there is no term, you just have minus 2, where in the y equals mx plus b format, you would normally have something in front of an x. That's missing. Let me show you why. When you're finding mathematical slope, that's change in y over change in x. So let's just pick a couple of these, and I'll show you what that slope is. Let's do negative 2 minus negative 2. underneath that, we're going to have 0 minus 2 to find the mathematical slope. Now, negative 2 minus negative 2 is the same as negative 2 plus 2, which is 0. The bottom is going to be negative 2. 0 divided by anything gives you 0, so your slope is 0. So the reason you see y equals negative 2 without an x term is your slope is 0. 0 times anything will cause that to completely cancel out. And since this crosses the y-axis, anytime that you are plotting a y equals, your line is going to be going through the number given, in this case negative 2. It's going to be perpendicular to the axis stated. Now with that information given, let me put 0 slope here. With that information, let's put x as 3. I'm going to get rid of this horizontal line that we just created. Alright, with x of 3, let's do the same thing with y. We can put in 0, negative 2, and 2 and plot some points. 3, 0 is the first one. 1, 2, 3. 3, negative 2 will be down here, and 3, positive 2 would be up here. So, just like the other one, it's fairly obvious when you connect these points. That's a bad line, but it's straightened out. Good. When you connect the points, you're going to get a vertical line. And notice it crosses the x-axis at 3. So, your original equation is x equals 3. When it comes to defining the slope on this one, let's pick a couple of our points like we did before and do change in y over change in x. So you have 0 minus negative 2 over 3 minus 3. Now the problem here is you get 2 over 0. This leads to the answer for the slope as being undefined. You cannot divide by 0. You can do 0 divided by and get 0 as your answer, as we did on our horizontal line, y equals. But when it comes to x equals, there's no way to write this in slope-intercept form. So you're going to have an undefined slope. That's not 0. That just means it's impossible. Can't do it. And I'll explain that in just a second. But look at your x-axis. Look at where it crosses. And then make it perpendicular. If you only have an x in your equation, your line will only cross the x-axis. For equation 1, you only had a y, and it'll only cross the y-axis, where that was a horizontal line. Right, so that might help you keep those straight, but those are very easy to mix up. Now let me explain this undefined versus 0 thing. In math, at this stage in math, you already know that division and multiplication are opposites. So we know that if 6 divided by 3 equals 2, then these two numbers multiplied, then 2 times 3 will give you 6. Okay? Same way, if you got 8 divided by 2 equals 4, then 4 times 2 will give you 8. So let's put that in for 0. If you have 0 divided by 2, the answer to that is 0, because 0 times 2 will give you 0. If I flip it upside down now, that's why you get undefined. What you got is 2 divided by 0. I have no way of answering that, alright? Because I can't do any number here times 0 that will give me 2. So what ends up happening is in math we call that undefined. I normally abbreviate it UNDEF. It's just a quick little side note. Alright, next page. We're done. In lesson 3. So on the next section we're going to do together, you're going to write equations and lines. And you're not going to use graphing on this. You're just going to write the equations given some information. And you're going to see some special scenarios, such as more about horizontal and vertical lines, which we just talked about, and parallel and perpendicular lines. So that's it for lesson 2.